Electrical load calculation for a commercial building involves several steps to ensure safety and code compliance. Firstly, determine the building's use and area. This is crucial for identifying the appropriate load requirements. Consult NEC Section 220.12 and NEC Table 220.12 for guidance. Secondly, determine the voltage and phase of the electrical system. This information is essential for selecting the correct electrical equipment and conductors. Refer to NEC Section 210.4. There is no specific table mentioned for this step. Thirdly, calculate the lighting loads. This involves determining the total wattage of all lighting fixtures in the building. Use NEC Section 220.40 and NEC Table 220.40. The appropriate column, whether warehouse and storage or other, should be chosen based on the building's specific use. Fourthly, calculate the receptacle loads. This involves determining the number and type of receptacles in the building. Consult NEC Section 220.41 and NEC Table 220.41. Fifthly, calculate the motor loads. This involves determining the horsepower and quantity of all motors in the building. Refer to NEC Section 430.22. There is no specific table mentioned for this step. Sixthly, calculate other loads, which may include HVAC systems, appliances, and other specialized equipment. Use NEC Section 220.11. There is no specific table mentioned for this step. Seventhly, calculate the demand factor. This allows for a reduction in the total calculated load based on the likelihood that not all loads will be operating simultaneously. Consult NEC Section 220.82 and NEC Table 220.82. Eighthly, calculate the service ampacity, which determines the size of the service conductors and of recurrent protection. Refer to NEC Section 220.41. There is no specific table mentioned for this step. To size the neutral and ground conductors, consult NEC Section 250.24. There is no specific table mentioned for this step. The NEC, or National Electrical Code, provides comprehensive guidelines for electrical installations. NEC Section 220 specifically addresses branch circuit and feeder calculations. Lighting load calculations for commercial buildings are also covered by resources like the Department of Energy. And electrical load calculations for commercial buildings are covered by the Civil Engineering Database. Each of these steps is critical in determining the overall electrical load of the building. Consider an example of a small commercial office building. Firstly, determine the building's use and area. Suppose the building is a 5,000 square foot office space. Using NEC Table 220.12, the unit load for office buildings is typically 3.5 volt amps per square foot. Secondly, determine the voltage and phase. Assume the building has a 120/208 volt, three-phase power supply, commonly used in commercial buildings. Thirdly, calculate the lighting loads. Suppose the office space has LED lighting fixtures with a total wattage of 5,000 watts. Convert watts to volt amps, assuming a power factor close to 1, resulting in 5,000 volt amps. Fourthly, calculate the receptacle loads. For office buildings, NEC Section 220.14 requires a minimum of 180 volt amps for each receptacle. Suppose there are 50 receptacles in the office space. The total receptacle load would be 50 multiplied by 180 volt amps, which equals 9,000 volt amps. Fifthly, calculate the motor loads. Suppose the building has a small HVAC system with a 5 horsepower motor. Using NEC Table 430.248, a 5 horsepower, 208 volt, three-phase motor draws approximately 16.7 amps. Convert this to volt amps by multiplying the voltage, current, and the square root of 3, which equals 208 volts multiplied by 16.7 amps multiplied by 1.732, which equals approximately 6,000 volt amps. Sixthly, calculate other loads. Assume there are several computers and printers with a total load of 3,000 volt amps. Seventhly, calculate the demand factor. Using NEC Section 220.42, the demand factor for general lighting in an office building is typically 100% for the first 125 kVA and then 35% for the remainder. However, this example will use 100% demand factor. Eighthly, calculate the service ampacity. The total calculated load is the sum of the lighting, receptacle, motor, and other loads. This equals 5,000 volt amps plus 9,000 volt amps plus 6,000 volt amps plus 3,000 volt amps, which equals 23,000 volt amps. To find the service ampacity, divide the total volt amps by the voltage and the square root of 3. This equals 23,000 volt amps divided by 208 volts divided by 1.732, which equals approximately 63.9 amps. To size the neutral conductor, NEC Section 220.61 allows for a reduction in the neutral load. In this case, assume a 70% demand factor for the neutral load. Therefore, the neutral load is 63.9 amps multiplied by 0.70, which equals approximately 44.7 amps. To size the grounding conductor, NEC Section 250.24 requires the grounding electrode conductor to be sized based on the size of the service entrance conductors. Based on the 63.9 amp service, a number 6 American wire gauge copper grounding electrode conductor would be appropriate. Remember that load calculation is a complex task that requires knowledge and experience. It is recommended to consult with a qualified electrician if you are not comfortable performing the calculations. Here are some important points to consider when performing a load calculation. Firstly, accurately determining the building's use is crucial. Different types of buildings have different load requirements. For example, a hospital will have a much higher load requirement than an office building. Secondly, the NEC is updated regularly, so it is important to use the latest edition. The specific code references and tables may change between editions. Thirdly, demand factors can significantly reduce the calculated load. However, it is important to use the appropriate demand factors for the specific application. Fourthly, motor loads can be complex to calculate. The NEC provides detailed guidelines for calculating motor loads, including lot rotor current and full load current. Fifthly, other loads, such as HVAC systems and appliances, should be carefully considered. The nameplate ratings of these devices should be used to determine their loads. Sixthly, safety is paramount when working with electricity. Always follow safe work practices and wear appropriate personal protective equipment. Seventhly, consider future expansion when performing a load calculation. The electrical system should be sized to accommodate future load growth. Eighthly, consult with a qualified electrical engineer for complex or critical applications. A professional engineer can provide valuable expertise and ensure compliance with all applicable codes and standards. Here are some additional resources that may be helpful. The National Electrical Code is the primary resource for electrical installations. The NEC Handbook provides additional explanations and examples. Professional electrical engineering societies offer training courses and certifications. Local electrical inspectors can provide guidance and interpretations of the NEC. Electrical supply houses can provide information on electrical equipment and materials. Online forums and communities can provide a platform for asking questions and sharing knowledge. Always verify information from online sources with reliable references. Remember that electrical work can be dangerous, so it is important to be properly trained and qualified. Understanding the basics of electrical theory is essential for performing load calculations. Ohm's law states the relationship between voltage, current, and resistance. Power is the rate at which electrical energy is used. Voltamps is a measure of apparent power. Power factor is the ratio of real power to apparent power. Transformers are used to step up or step down voltage. Conductors are used to carry electrical current. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. Grounding is used to provide a path for fault current to return to the source. Bonding is used to connect metal parts together to create a low impedance path for fault current. Electrical drawings and diagrams are used to communicate electrical designs. Understanding electrical symbols and terminology is essential for interpreting electrical drawings. Computer software can be used to assist with load calculations. These programs can automate the calculations and provide detailed reports. When performing a load calculation, it is important to document all assumptions and calculations. This will help ensure that the calculations are accurate and can be easily reviewed. It is also important to keep records of all electrical work performed. This will help with future maintenance and troubleshooting. The electrical systems should be inspected and tested regularly to ensure that they are operating safely and efficiently. Regular maintenance can help prevent electrical problems and extend the life of electrical equipment. When working with electricity, it is important to be aware of the potential hazards. Electrical shock can be fatal. Electrical fires can cause significant damage. Arc flash can cause severe burns. Always follow safe work practices and wear appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. A qualified electrician has the training and experience to perform electrical work safely and correctly. The goal is to ensure that the electrical system is safe and reliable and meets the needs of the building's occupants. By following the steps outlined above and consulting with qualified professionals, you can ensure that your commercial building has a properly sized and safe electrical system. Remember that load calculations are not static and should be reviewed periodically, especially when there are changes in building usage, occupancy, or equipment. This ensures that the electrical system continues to meet the demands placed upon it safely and efficiently. Furthermore, advancements in technology, such as energy-efficient lighting and equipment, can impact load calculations. Staying informed about these advancements can lead to more accurate and efficient electrical system designs. Finally, always prioritize safety and consult with qualified professionals when dealing with electrical systems.